So good afternoon and welcome to the breakout session, Accelerating the Transformation to the Cloud. My name is Jake Smith. I'm from Intel's Advanced Server Technologies team. Joining me today is Rekha Raghu, who's also a member of our Software and Services group, and then Bob Maynard, who's from Univa VD. So with that, I would like to remind everybody that today we have a drawing for a new Acer Atom Aspire 1. Those must be present to win at the end. Tim Allen, who helped organize this wonderful event for us folks here at Intel, has put together this drawing. So I want to thank you all for coming today. So the agenda for today is really, really simple. We're going to talk about our vision for the cloud. We're going to talk about architectural requirements. Rekha and Bob are actually going to talk about the work that Intel is doing through our Cloud Builder program, working with VMware and accelerating your journey to the cloud. And then we're going to have a little summary and a little bit of time at the end for questions and answers. So we'd like this to be very interactive, so if you feel like you have to ask a question while we're going through the presentation, please go up to the microphone and ask the question. This session is being recorded, and we want it to be very clearly heard, your question, for those folks who are listening on the web or are going to download this at a later date. The one thing that Intel has been sure of, and as many of you probably read in the Wall Street Journal, it's been announced on many analyst blogs, we just purchased or agreed to purchase two companies in the last 10 business days. We moved forward with our bid with the German wireless organization Infineon AG, a division of that organization. And for those of you here in Silicon Valley, we tendered our offer with board approval for McAfee. Now, why did we do this? And why would Intel start buying companies that may seem to be a little bit outside of our core Intel architecture? Well, two reasons. The internet is exploding. The internet growth rates, while many people are calling for a slowdown, we're calculating internet growth rates to be doubling over the next 5 to 7 years. If you take a look at the worldwide population at the end of 2010, roughly 1.8 billion people were on the internet. As you move forward to 2015 and beyond, we see that number growing by at least 1 billion people. How many of you carried a smartphone 5 years ago? 8 years ago? 10 years ago? How many people carry a smartphone today? 90% of the room or more. Okay? Smartphones drive traffic on the network, they drive servers to stay connected with them, and they drive an explosion of growth. How many of you use some kind of connectivity in your car? Let's just call OnStar here in the United States. How many people use OnStar today? How many people used OnStar 5 years ago? How many people believe that in 5 years you'll be using some kind of infotainment network when in a vehicle? How many people? Roughly 70% of the room. So we went from 10% to 70%. All of that is going to drive requirements in the data center. Many of you are data center system administrators, you're data center architects, and you're being asked to do more with less. Okay. First of all, I want to thank you because what you have done over the last 4 to 5 years in the face of the worst recession in all of our lifetimes is you've been able to deliver value to your organizations. Otherwise, you wouldn't be here. They wouldn't have paid for your plane travel to get here. And you're going to continue to deliver value to the organizations because you're going to find ways to do more with less. It's our job at Intel to really help you drive that exponential growth. And we believe that with the same financial footprint that you're spending today, we can drive those initial steps towards what we call the billion virtual server cloud. Let's see if I can get this right. Now, when you're considering cloud deployment today, cloud has been around a long time. I've been blogging about clouds. I've been working on clouds and ASPs for about 12 or 15 years now. And when you think about what you're being asked to do today, you're being asked to make considerations when you talk about cloud computing between what do I do inside of my firewall, or as we say at Intel, our four walls, and what do I outsource? What do I look to deploy on Amazon EC2? Where do I look to find a fit for Google Apps? Where does Microsoft Azure play? Is Terramark where I should be doing my business, or should I be doing it with Savvis? These are questions that we have to ask ourselves as IT management teams. And when we look at these architectures, we also have to determine, are we going to be able to build enough capabilities to have that brokering or that virtual private hybrid cloud? Now, VMware is going to do a great job over the next couple of days and talk to you about the technologies they're developing. Intel's working side by side with them. As many people know, we are an investor in VMware, and our relationship is very deep on both the technical, business, and marketing front. But as you look at these, you have to make some of these decisions. Inside my private cloud, is that best for security? Is that best for ERP? Is that best for Exchange? Where does that virtual private cloud, what role does that play for my business units? And am I going to be able to deliver the value that the business units expect? But then when you look outside and you look at the public, you have to ask yourself the question, am I going to be SAS 70 compliant? Am I going to be PCI compliant? And I don't mean interconnected devices here. Am I going to be PCI compliant, or am I going to be Sarbanes-Oxley compliant if I move those applications out into the public cloud? These are considerations that we have to make. Intel is going to be working with the industry to develop a set of usage models and reference architectures that make it very clear on how you as a system administrator and how you as a data center architect can go ahead and deploy these cloud infrastructures and know it just works the first time you deploy it. So when we talk about what are these cloud architectural requirements, we really think of three things. And we have this underlying belief that the cloud architecture is open. The cloud architecture is interoperable. Okay? That includes Intel chips. Hard enough for many people to believe that. But we believe that we're going to stand on our own merits based upon the technology that we deploy and the ecosystem that we develop and the partners who we work with. And we're going to spend a lot of time listening to customers. We're going to spend less and less time dictating to the industry, if you will, and maybe my lawyer will come back and say, don't say the word dictating, but telling the industry what technology we're deploying, and more time deploying the technology that you as system administrators and data center architects tell us we need to deploy. And the three tenets that we have been hearing over and over again from our enterprise board of advisors, our communication board of advisors, and hopefully some of your companies are part of these board of advisors, and we're going to be expanding this very soon, is that the technologies are efficient, they're built for optimization in power, they're built for optimization in human consumption, they're built for optimization in code, okay? That they're simplified, we reduce cables, we reduce physical footprint, okay? We reduce consumption of greenhouse gases, and then the secure. Number one issue that we hear over and over again is security. So we're going to focus on these three areas. So you say, well, does it make sense? Why did Intel buy McAfee? Well, you heard, if you read any of the announcements, we talked a lot about security. Security is a core pillar of what Intel is going to be delivering in cloud computing now and into the future. So what is our vision? Okay? You say you've acquired these companies, you spent $9.2 billion in the midst of a recession to acquire two companies that maybe we don't understand. You're standing up here talking to me about a vision for cloud that I've heard half a dozen times from 15 different vendors. Well, there's a reason. We do business with every one of those vendors. So our vision is about executing in each of these core areas. Executing a federated strategy. And Bob's going to come up and talk about how we've developed a reference architecture with Univa that is a first step in that federated and automated strategy. The ability to move data seamlessly and securely between both private and public in a federated fashion, a term that VMware and Intel have been working on for some time. In an automated fashion, using dynamically capable tools like the dynamic resource scheduler, using technologies like enhanced vMotion and Intel VT Flex migration, the ability to set business rules and policies that allow you to actually move virtual machines and workloads from private to public and back again to find the most dynamic and capable place to run your workloads. And then finally, client aware. Our 2 acquisitions that we've made over the last 10 days have been focused in this client-aware space. They've been around security in the client, and they've been around baseband smartphone capabilities and the ability to move into next-generation technologies and move those next-generation technologies into the cloud. Not into the cloud where I can just go check the weather. Well, we can already do that. But provide the capability for you to program using these devices like this Atom netbook that somebody will win at the end of the day, like an iPhone, like a next generation BlackBerry, and like the normal laptop and desktop environments that you guys have become accustomed to. So our strategy around optimization is very clear. How many people knew that Intel employs almost 10, now, since we hired over 14,000 software engineers? Dave Martin from VMware. Thank you, Dave. I'll buy you a beer later. We are one of the largest employers of the world of software engineers. And what those software engineers do is they optimize our silicon technologies to run the very first time. We're going to deliver optimized silicon. How many people think Intel's going to deliver optimized silicon over the next 5 years? Okay, thank you. Everybody, that was a call and response. I was hoping for a 100% hit rate. I just missed. So this is what we do. Optimized technologies. You're going to see us deliver technologies around power consumption, around security, technologies you haven't seen from Intel before. Now you're going to see us deliver technologies around baseband. Doesn't sound like a very big deal, okay? Baseband security technology is a pretty big deal if you're trying to securely access your network via a smartphone. Probably want that to happen. We're going to deliver scalable software for the first time in our history. Scalable software that partners with the likes of VMware and Univa and Microsoft and the industry. We're not going to compete on the merits of our software from an application stack. We're going to partner and deliver a broad ecosystem for you as end users to take advantage of. And we're going to deliver optimized systems. We work very closely with the industry today, the IBMs, the Dells, the HPs, the Ciscos. That work is going to continue. The network appliances, the EMCs. You're going to see us optimize storage technologies as well. And finally, we're going to look to deliver data center optimization. You're going to see Intel play a role in what do we do about power and cooling. How many people run their data center at 62 degrees? 66 degrees. 78 degrees. Who runs their data center at 78 degrees? Excellent. If you run your data center at 78 degrees, what do you think your power cost and your cooling costs are versus the team that runs it at 62 degrees? Well, markedly better. Probably 20 to 25% cheaper. And depending on where you are, it might even be more. So you're going to see Intel spend a lot of time there in delivering technologies that show how to apply business policies and rules, not just in the server, in the rack, and at the whole data center level over the next couple of years. So an example of 3, and I'm not going to spend a lot of time here because I want Reka and Bob to be able to get into the work that they've already done, but this is the work we're doing right now with VMware and we've talked about trusted compute pools and the ability to actually take workloads and ensure that when you dynamically allocate a virtual machine to physical node A and transfer it to physical node B, you do so in a way that allows you to ensure that it is trusted migration. And when that boot up happens on physical node B, you know that you've done so on a trusted physical machine. And you actually have the logging capabilities to ensure that you meet compliance. Many of you have compliance issues out there. We know because you're telling us this. Second thing we're doing is we're working with the industry to deliver what we call policy-based power management. The ability to set business rules based upon workload consumption. So that you can say, when I have 80% utilization on my server, I'm going to increase the cooling in my data center. Doesn't sound like a big deal, but if I'm at 5% consumption, 5% utilization of my server, do I want to have a 62-degree data center? If I have 1,000 servers, that gets to become a very expensive proposition. So we're going to begin to take on these capabilities and deliver technologies like Node Manager. We're going to do so in an open fashion. And then finally, we're going to work with the entire industry. And Reka is going to talk about the Cloud Builder program that we launched in October of last year. And we are going to provide a framework of reference architectures to allow the industry to do cloud onboarding so that when you deploy technologies and you see these reference architectures on the Intel sites, you know they've been tested in a lab, the cloud onboarding technology works, and if you follow the reference architecture, you can deploy that inside your data center. So before I hand this off to Reka and she talks about the Cloud Builder program, I just want to thank you and appreciate you guys. Give us some feedback on our vision. We're going to be rolling this out over the coming weeks and coming months, and we look forward to your feedback. As I said before, we're going to build technologies moving forward as we move into this era of cloud computing, based upon technology feedback and based upon delivering more with less on a Moore's Law beat rate. So you're going to hear us talk about the tick-tock of delivering these capabilities over the next couple of years. And with that, I'm going to turn it back over to Reka.
Thank you, Jake. So Jake talked about our vision and our strategy. Now what I'm going to talk about is the execution piece. Cloud computing takes the compute, network, and storage resources and offer them in a shared resource pool environment. While you do that, you also want to have capabilities of federation. You want capabilities of a self-service portal and provisioning. All of these need to happen in automated way. However, while it seems simple enough, but actually to implement something like this is pretty complex. I'm sure how many of you have, while you're trying to set up a cloud, I mean, you look at the different options, right? I mean, you start to look at what are the different hardware combinations that you can use. What's the software? There are several software vendors that are available, including VMware. There's Universe, another one. There's several players in the industry that offer the infrastructure as a service software. And what type of skills do I need from my developer perspective to actually build this cloud? And who is going to write to my self-service portal? And what are some of the things like compliance and security and availability that you need to consider? So it's always a challenge, really, while talking to end users like you, is really the problem of figuring out where to start. So, and it seems like a pretty complex process from what we've learned, at least. So I'm not sure how many of you already have a private cloud running in their environment. Okay, so as you see, it's still Okay, so with that in mind, what we launched, like Jake said, in October of last year, our Intel Cloud Builder program. Our primary goal here is we are partnering with several of the ecosystem players, VMware being one of them. And our primary goal here is to provide a starting point to build a cloud to our end users. So this program is targeted for service providers, hosters, and enterprise ITs. And onto the right side is one of the pillars here is the deployment of best practices. This is the primary pillar of the Intel Cloud Builder program. What we do here is partnering with the key ISV stacks like Microsoft and Citrix and VMware and several others that are listed here. We jointly develop a reference architecture that highlights the Intel-based servers and their software partner stack. Our goal here is to, again, like I said, to provide a starting point and a reference point for people who are trying to build their cloud environment. And the middle vector is the optimized clouds. Not only we need to build a cloud, we also need to make sure that the service providers, when they're building their cloud, they want to make sure that the cloud is optimized and highly performing and also addresses the demands of their customers in terms of SLA. So here's where we can take advantage of Intel technologies like Intel TXT, trusted execution technology, or in terms of power and cooling, you can do Node Manager, and our Intel servers themselves like 5600 series, which is the latest series that we launched. So we work with end users in this phase where we deliver proof of concepts where we can highlight our technologies and help the end users to take advantage of our technologies. And the third pillar is the research area. Intel has also invested very heavily in cloud computing research. We have a test bed that spans over like different worldwide. I think we have about 10 test beds worldwide called OpenCirrus, which is offered jointly by HP, Intel, and Yahoo. The primary goal here, again, is to foster an open community into the research areas. We, again, have a lot of best practices and BKM sharing and even benchmarking and several areas that we look at. If you go to opencirrus.org, you can learn more about this. And Intel also works very closely with Berkeley's RAD Lab, again, into working on several of the advanced research topics. So the primary goal here is to help a developer, any type of ideas that they may have, take that and convert that into a complex deployment solution. So the Intel Cloud Builder is a platform, as we see, is to jointly work with our ecosystem partners and to offer the solutions to the end users like you. Okay, so I talked about this reference architecture, so I'm going to drill down into the detail. What exactly is the reference architecture contain and what is the process? The key thing I want to highlight, stress here, is this is not some marketing collateral. This is actually a technical content that we jointly work together with our ISV partners. We actually we spend engineering time jointly with ISVs and Intel engineers. We develop a series of hardware blueprints that documents the specific hardware configurations and details that are required to build this particular cloud stack, along with our partner software stack, which again describes the partner features and capabilities and overview of the product itself. And we jointly define a set of use cases, which we then run on a test bed that Intel is hosting. We have these test bed again worldwide. And we run these results, and then we document these in form of a white paper. And it also contains things to consider when you actually scale out. This is, I want to kind of stress here, this is not it's a large scale solution, but it's obviously not by means end all solution. This is going to be a starting point, like I said before, to how to build a cloud, and then we are also adding technologies and capabilities to show how to optimize a cloud. So the list down here is the key partners that we have, and as I speak, the list is growing tremendously. So the Intel.com, the website URL is there. So Univa is also one of the partners, and so is VMware. So here's a website just to give you an idea what we have in here. And like I said, the reference architecture is extremely detailed. It's meant to complement the ISV software product installation guides, and it's very detailed. And on the website, we have about 4 of those with Univa, Anomaly, Parallels, and Canonical to this date, which you can actually see some of these contain scripts or commands or screenshots of detailed implementation of what we've done. So the primary focus of our Cloud Builder program as of now is the infrastructure as a service. So we require that the cloud management stack needs to be infrastructure as a service, and we do dictate a specific set of guidelines. We want to make sure that the software stack offers self-contained compute and storage resource pools via either a self-service portal or by an API. It also needs to have capabilities to manage the hardware components, whether it may be compute, storage, or network. And there are some additional deadlines, feature capabilities that we also add, like billing or metering, power management, automation, several other things. Each software stack may also have some unique capabilities they may bring in. So our goal here is to bring the value of these unique ISV products on Intel, to run the best on Intel. Here's an example test bed that we have in our Oregon lab. We have about several racks of servers and also the network being 1 gig or a 10 gig network. And typically we provide remote access to our ISV so that they can configure and set the setup, and we work with them in installing and running the test scenarios. Okay, so we've done this through over more than about 8 or 9 of these ISVs to this date, and we've got quite a bit of key learnings that we've learned jointly by working with these several partners. One of the fundamental things, like I said again, is making the process of building, making it a lot simpler to use by having a standard Intel building blocks. We've definitely found that it's benefited our customers. And scalability, another area that often that you want to make sure that you address is when you're building a cloud is to address for peak traffics. You want to make sure that you consider all your deployment sizes and growth of your customers. And also make sure that while you're designing your cloud, you also have capabilities that you can onboard your application or cloud burst into a public cloud when there's some sort of an overspill that could happen. And security is the number one problem of the cloud, especially in the public cloud space. So you want to make sure that if you're going to have multiple tenants that are going to be running using your cloud, you want to make sure you have the right amount of isolation in terms of network or instance. efficiency, again, as a cloud provider, you want to make sure that you can deliver your customers SLAs. So to do that, you want to make sure that you have capabilities and infrastructure that you provide has those capabilities. Things like you can use solid-state disks for any type of data-intensive components. And the most important of all is to make sure that you understand your customer requirements, exactly make sure that you know what their server footprint is in terms of the network and the server and the storage, and plan your data center accordingly. So working with our partners, again, and talking to some of the end customers, we found that our Cloud Builder program brings a great value to the end users like you. The fundamental, like I said, is the problem of what are the questions that you need to think about when you're trying to design your own cloud infrastructure. And cloud is still new. Often people still don't understand the concepts. Our goal here is to help simplify that process. And this is our medium, again, to actually showcase some of the industry-leading capabilities like virtualization technologies and Intel Trusted Execution Technology, etc. From ISV themselves, what they've told us is it has helped them, from their perspective, as a medium for them to showcase their solutions and document their best practices. It's also provided them a means by which they can validate the software stack. Sometimes it has helped them find issues. As you probably know, the cloud management software vendors are still in their infancy, and a lot of them are still growing and pretty much launching their products as we speak. So it has helped resolve issues, and in certain scenarios, we've actually also helped them identify additional requirements. For example, one of the ISVs actually did not have a mechanism for installing a lot of they had a manual process of installing everything by scripts. After they worked with us, they actually added in their next product release of an automation capabilities where they could have an automation of installation that could happen for their product stack. So in reality, what it has provided is for the ISV themselves is a medium for being able to actually access to a real engineering test bed and access to our great Intel technology experts. And finally, Intel being the trusted advisor and well-known in the industry, it has given them an opportunity to bring their visibility on their products. So tying back to what Jake talked about, he talked about how we are working with the industry to define several usage models to address pain points in the industry. The first one, what I talked about so far, is the standing up to the cloud or infrastructure as a service. And there are additional usage models he talked about. What I want to talk about now is how we're also using Cloud Builder as a mechanism to showcase, build reference architectures, also to address these usage models. One of them is the trusted compute pools, so I would like to walk through that. Okay, security is the number one problem in the cloud, and the threats that are occurring are getting more sophisticated day by day. And the malicious software, the way to detect them, instead of just detecting them, the easier way to do that, or the better way to do it, is really to build a trust in your platform and a trust of your software. So that's where Intel Trusted Execution Technology feature comes in, where you build a level of trust all the way from the platform all the way to the software level, especially at the hypervisor level, such that you have a set of trusted pools in your data center. So this way, also, when cloud computing, what it is doing is basically taking the physical servers and converting them into logical virtual machines. So what happens then with an IT manager, when they are trying to run these different resources, they are basically going to allocate them based on certain rules related to either high availability or resource allocation. You have no control in terms of where your processes or data is going to be running, right? So that means it's going to be harder to enforce any type of compliance or regulatory compliance policies. The other issue also is the multi-tenancy, right? Like I said, your server, whatever you may be running your applications on the cloud, but you have no control on what other things or who else is running on the same cloud, which means you have a risk of not trusting the infrastructure itself. So what with our Intel Trusted Execution Technology and the specific usage model, what we're trying to do here, specifically partnering with HighTrust and VMware in this particular example, we boot the hypervisor in a trusted manner using the Intel TXT. And when you add a server, we then add a server. When we add it, we enforce it and say that it is a trusted pool of servers. So when a specific customer that wants to bring an application to this cloud, and if they have a specific request that they would like to be on a trusted pool, then they make that request and we make that allocation of that, and they bring that application onto that. So to see this in action, and then when they actually, migration scenarios could happen, right? Like I was saying, anytime, if depending on the high availability or a resource allocation, the cloud may move your VMs to another server that may not be trusted. If a rule is set up in such a way that you will not be allowed to do that, using this high trust example here in this particular scenario, when a request from this console comes to migrate this VM to platform 2, if a rule is set up on the high trust, this particular request will be rejected. So what this means is, thus by establishing the trust at the hypervisor level, now you can actually utilize this particular trust level to address any type of migration or deployment decisions. With that, like I said, Jake said also, Univa UD is one of our partners of the Intel Cloud Builder program. We have run through the Cloud Builder infrastructure as a service use cases with them, and we have documented the results in form of a reference architecture, which is available on our website today. So I would like to invite Bob Magnard, who is from Univa UD, to talk about his experiences of working with us on the Intel Cloud Builder program. Thank you.
Thank you.
Oh, God, it's good.
I'm not going to be able to speak as fast as she does. Very nice. Nicely done. We were very excited about joining the Intel Cloud Builder program because we've been working with our customers in helping them figure out the right ways to go about utilizing internal and external clouds, as Jake said, within the four walls, and then determining which applications, workloads were best fit for going to a public cloud or tying a public cloud into and making it look like to the end user as a single cloud. And that's really what we've been doing, focused on primarily over the last year. So having the opportunity to work on this reference architecture was a great benefit to us. We've always had a focus with working on partners. As I talk about some of the products that we use and develop, we have a lot of other vendors, ISVs, products that we use to accomplish this, any app, any cloud, one path. And we're the one path, we think. We're the ones that tie the clouds together. We can, through policies, make sure that the workloads are growing to the right place. And we'll talk a little bit about that. But the actual use case that we went through is something that we've done for some others in the past, but this was a great opportunity to work with Intel, VMware, and others on the storage side as well. So this is really our focus, is allowing enterprises to tie together internal and external clouds and make it look like a single compute farm in the proper manner and do it dynamically. So what we really call, and we say that when I say we, Univa looks at the hybrid multi-cloud as not only your internal going to a public cloud, but then being able to dynamically move that workload from one public cloud to another in a dynamic fashion through policies. So you ensure that you're taking that workload in the proper manner and moving it to different infrastructures for the best. We have some customers that look at it from a spot pricing standpoint, trying to figure out, is Rackspace a better price today for this type of workload, or is it Amazon, or is it Terramark? So we are able to, through policy, set those and set it up so you can actually automate the process of doing that. And so when you look at hybrid, it's internal, external, obviously multi data centers, and then the actual cloud is virtualizing on demand in the proper manner, using on demand for your workload. And we've looked at the building blocks for this, and this again is where we provide for our customers and for even service providers we work with the ability to on-ramp a customer from a service provider standpoint, and then also from the enterprise, the end user, we give them the ability to, through a self-service portal, take that workload, stand up an instance, and then break it down when you're done with it through a self-service portal. And we also give that capability to the service providers as well, and that was part of this use case as well to prove that. And then, as I said before, we focus on policy management, so you're not allowing people just to do this based on, what they think they might need, but you actually start building policies on how you've done this, and then creating those policies to automate what workloads should go where, when they should do it, so you ensure that, you're not over-provisioning or under-provisioning for a particular situation. And then the cloud management software, that's really what Univa provides, is that cloud management to ensure that we are moving that workload through the cloud in the proper way and connecting and provisioning that in a timely, seamless manner. And then working with the hypervisors, and obviously VMware was key in this, and we also work with the vSphere and integrate with that as well. We're working on that integration, I should say. We actually did another benchmark about a month ago with ESX just on proving the application degradation to ensure that there was much less than people expected from virtualized applications. So that white paper is actually going to come out, I think, in the next month. But and then account management, obviously we have to integrate with Active Directory or any other LDAP directory that you would use. So those are really the software building blocks in doing this. The actual reference architecture, I'm not technical, so I'm not really going to tell you about each one of those boxes, but the first three blocks, we've broken into 3 blocks. So the top is really where you start with UniCloud, UniPortal, and Active Directory, setting it up. And then we create an installer node in the second block, which is where where we go out and install the VMs, tie the compute nodes and storage, and then we create the actual clouds and tie them and move that workload into the different clouds that are appropriate based on what the administrator or the particular user needs at that particular time. And you can go to the Cloud Builder website to see the architecture. So the value to the users that we found and when we've worked with them is really the flexibility of focusing on not only your own compute infrastructure and maximizing that, because through UniCloud we can actually provision from bare metal to hypervisor back to bare metal depending on the type of workload. And then we can also stand that type of environment up in a public cloud and move that. So it's the flexibility, again, policy management in terms of creating a very secure, thoughtful way of moving those workloads. And then really extending the capacity when it's needed. And obviously business agility. Virtualization was really consolidation initially, and we look at it now, and I think through this reference architecture and what we've done in this use case is we've proven that virtualization really becomes mobility for you. Finding the best place to run a particular workload based on whatever those needs may be, whether it's pricing, whether it's just flexibility, whether it's peak situations where you need more capacity and you don't want to have servers set aside. We make sure in this use case, you can go back to the use case and see that we've set up the standards for which you can start thinking about how to do this in your own enterprise. So the best practices that we've taken from this are really the 5 that we've meant here. Obviously, you need to create goals. You have to understand exactly what you want to do in terms of your environment. What are the things that you see that could help you run a better enterprise by extending it in a very secure manner across multiple clouds, and then looking at the providers, and you talk to those providers, and you want to understand how they're going to handle your service levels, and make sure that when you go there, what is it that you're going to get from them, and how do you actually manage them to that? And we can help you through our governance to do that, and then technically be prepared. Obviously, you need to have a very good idea of secure connection, how you're going to move from one public cloud to another. What are the best ways that they're going to provide you with the right type of compute and storage? So all those things need to be planned out ahead of time. And then the mobility, which I talked about, which is really being able to move those in a way that reduces the manual effort to a point where the automation takes over and really makes it a seamless effort and something that is in real time versus building up staff and trying to figure out, how do I create an API connection to Amazon or to Rackspace or to Terramark or whatever, and automating that process. I didn't know it was that. Sorry. Jake, back to you.
All right. Thanks, Bob. Okay, now over the next couple of minutes, are there any questions out there? And I want to thank Bob and Reka. Are there any questions for Intel or the Cloud Builder program? If there are, please come up to the mic and ask those questions. We're happy to answer any questions the crowd might have. And your name and where you're from would be great for the audience listening at home.
Jason Mendenhall from Switch in Las Vegas.
Okay.
Could you talk a little bit about the Cloud Builder program, the reference architecture and its relationship to Cisco's vBlock and how that plays into that program? There was didn't get mentioned in there, but it seems to be something that's being talked about by all three parties, including Intel, at the VC Alliance.
Yeah, so we're actively working with the VCE team. Love your data center, by the way. And I think look for more things to come from. I can't unfortunately talk publicly about the things that we're talking about behind closed doors yet. Look for the opportunity. We were hoping to have something done by VMworld. It didn't happen. So look for something in the near future where we can discuss exactly how you could deploy a reference architecture using vBlock and that technology. Dave, is that the right answer?
Yeah. Good answer.
Checking with my VMware buddy here. Okay. Any other questions? Are we just down to the drawing? Or are we that boring? Long day after lunch. Tough crowd. If there are no more questions, I just want to thank you very much.
Yes.
And before you leave, somebody might win a netbook. Even if you don't want it, I'm sure your teenager or niece, nephew, or child will.
So, before we draw it, I want to explain a couple other opportunities to win. I handed out some cards. You have to put a stamp on this card. If you didn't get one, come to me afterwards. All you have to do then, from this point on, is go to 2 demos. And then on Thursday, we're going to have a grand prize. We're going to give a Core i5 top-of-base laptop. We're also giving a Core i5 laptop on Wednesday in the Super Session. Jake will be
presenting along with a member from our Intel IT staff on our internal cloud deployments. And we actually have quite a large cloud, so this should be fun.
So that'll be an opportunity to win an Apple laptop, $1,000 American Express gift card, and another netbook. So there's multiple ways to win. It's not just today. So come and see us in booth and questions.
So I just
go on Wednesday to Jake's other session.
So I just want to add one thing. I just want to throw out the Cloud Builder website for your reference, and it's www.intel.com/software/cloudbuilder. You can also Google on Intel Cloud Builder. You can probably find it.
Okay. I'm not looking.
Now, the first thing is if you have to be excited. If you're not excited.
Okay. B52.
Oh, boy.
Oh, just kidding. Okay. No. 077324. Bingo!
Guys, please.
All right, thank you all very much.
You.
Enjoy
Thanks,
the show
everybody.
here. Thank you very much.